Alright, today's lesson is on solving linear systems. For the most part, we're going to be seeing three variable systems. As far as going back to Math 1, when you learned about two variable systems, just a few reminders of when you graphed them, because that'll be helpful to know today. When you had two lines that intersected, the intersection would be the solution, and this would be an example of something that's just one solution. Whenever you had two lines that graphed that were parallel, that would be an example of no solution. But what you would also say was inconsistent in that scenario. By the way, this over here is consistent. It's consistent with one solution. The last situation you came across in Math 1 was where you would graph a line, and then the other line actually ended up being the same line. They'd be two lines one on top of each other. So all the points on the line would be solutions. So this would be consistent as well, but it would be consistent with infinite solutions. So now we're going to keep that in mind as we go through today's lesson, and on the video I'm going to be teaching it only with the Desmos calculator. You can do this with substitution and elimination as well, so keep that in mind, and I can teach you that during Smart Lunch or in class. Alright, now I'm going to go ahead and take my Desmos calculator and I'm going to type all these in. I'm going to go ahead and show that in live action because on the very first one something interesting happens. So I'm going to go ahead and type in 4x plus 2y plus 3z. Now I'm going to hit the ABC and I'm going to hit Z. And when I do that, it brings up an option to add a slider for Z, and you will want to go ahead and do that. So Z is now any value that you choose to be along this slider, and then it equals 12. Alright, next up is I just got to type in the other two equations. I'm going to do that in the third and fourth boxes really quick. Alright, I've already typed those two in. Now what I'm going to do is take a look at my graph up here really quick and see the three representations of these lines. Now, this is graphing these lines on 2D while they are actually three-dimensional. I'm just assuming Z is 4.5 at the moment, but I can actually change that Z value, and as I do, it's going to change how these things line up. Now, what you're wanting to do here is you are wanting to move Z around until all three lines are concurrent, meaning they intersect at the same place. And that looks like it's happening at 2. Most of these answers are going to be integers. So now that I think that that's my solution, I'm going to zoom in on that up here. And sure enough, they are concurrent there. And I'm going to tap on that intersection and see the answers for x, y, -1 is x, 5 is y, and I know that Z already was 2. And these are my solutions. So I'm going to present my answer as -1, 5, 2. X, Y, and Z. That's called an ordered triple, and this is how you present your answers. You can also write them out. X equals -1, Y equals 5, Z equals 2. But this is fine right here if you do this. If they're using other letters besides X, Y, and Z, I would advise just writing them out usually. Alright, so here's example 2. I'm going to hit the little home key to undo any zooming I did. I'm going to go ahead and type these out. Again, I'm going to add a slider for Z when I do that. Alright, so you can see that I've already typed these in. Also along the way, I added a slider for Z. I'm going to zoom out just a little bit so I can better see what's going on here. And I'm going to adjust Z until they intersect at exactly one point. I'm getting further away, getting close, and it looks like it's going to be at -3. Again, usually these are integer answers. Alright, so now I'm going to tap on that intersection. I will zoom in just a little bit to make sure that that's looking good. It is. So there's my X value of 2, my Y value of 4, and I now know that my Z value is -3 when they all lined up. So I'd present my answer as 2, 4, -3. If you want to make a note for yourself that this was X, Y, and then Z, that's great. What you're going to also run into occasionally is that you're not going to be able to adjust your slider far enough for them to intersect. So you'll either tap on the -10 or the +10 to actually adjust how far you can take z out to. Maybe you need to go to -20 and +20. And now when I tap on another equation, I can actually adjust even further out. So if your z value ends up being something further out between -10 and +10, tap on one of the values at the end, so that way you can change that range that you can change z between. All right, go ahead and see what kind of unique solutions we might have here. All right, same deal at the beginning. Go ahead and graph these out. Something different will be happening on these problems though. All right, so I've already graphed all of them, added the slider for z. I'm going to go back to where z is the slider, and I'm going to slide this around now. You might think to yourself, oh, they're not intersecting at one point. I need to extend my range for z. Before you waste your time with that, notice in this case, the blue and the red lines there. And what you're going to see is those are actually parallel. So no matter what I do for z, the three lines are never going to be concurrent. Okay, they're never going to intersect at exactly one point. So that's a situation where you have no solution, that they are inconsistent. You'll see either answer presented. I believe our textbook more often uses inconsistent, so I'm going to actually use that. And that would actually be it. No solution. I can't get this to work out. All right, here's my next to last example before I show you what a word problem perhaps might look like. And you're going to see same kind of deal at the beginning. So let's go and get started here. All right, so I've already graphed that out and added the slider. You might say to yourself, oh, I've actually already got my answer here. That's so easy. X is 5, Y is 0, Z is 1. However, that's kind of a little bit of a trick here. If you'll actually slide the slider around, you're actually going to see that's the same solution no matter where you take this thing. And obviously the z values are different here. So what gives? This is actually a case where they are consistent because they intersect at one point. However, there's infinitely many points where they do intersect, so it's actually infinitely many solutions is my correct answer here, because it really didn't matter where z was, it was going to intersect at one place. So infinite solutions. You will also occasionally see where it'll look like two lines are graphed and they're intersecting at one place, but really the third line is just sitting right on top of one of the two lines. Will also be infinite solutions as your answer. These are the two unique solutions that you might see: inconsistent and infinite solutions. And there's that. Let's go ahead and take a look at the word problem. Alright, this is a very run-of-the-mill kind of problem that you would deal with systems. Usually in Math 1 you've seen it with just two types of coins. Here in this kind of problem we're going to have three different coins because we got three variables to use now. So they like to take advantage of that. Colin has $1.27 in quarters, nickels, and pennies. He has twice as many quarters as pennies. He has 11 coins total. So first thing I'm going to do is really quick just define everything. I'm going to make X my quarters. I'm going to make Y my nickels, and Z my pennies, and that's just simply so I can keep it as typical with X, Y, and Z. You could use other variables if you'd rather, but it's just easier if you try to make X and Y two of your variables. All right, he has twice as many quarters as pennies. So the number of quarters would equal 2 times the number of pennies. To Z. That way, if I double the number of pennies, that would equal how many quarters he has. Alright, he has 11 coins total, so X plus Y plus Z would equal 11 coins total. That's a second equation. I do have a third. Since I know the value of all these things is $1.27, and I know the value of a quarter, a nickel, and a penny, I can actually make an equation there. Every quarter is going to be 25 cents, so 0.25 times however many quarters I've got, plus my nickels are 5 cents, so 0.05 times however many nickels I have, plus my pennies are 1 cent, so 0.01 times however many pennies I have, has to add all up to $1.27. Now I've got three equations. I can do exactly what we've been doing. I'm going to go and plug that in the calculator. All right, that worked out just the way it did before. The one slight little hiccup here was that it did bring the slider in later because the first equation had only 2 variables in it, but it did nonetheless. All right, so I'm going to really quick just zoom this out so I can take a nice overall look. I do know here that my answer has to be integers. If ever that's the case, you could actually change, because I can't have half of a coin. I'm going to actually change my slider to still go from 0 maybe out to 20, and the reason why I'm putting 0 there as a boundary, well, I can't have less than 0 pennies. It would be impossible for me to have negative pennies, and I'm going to have it only step by ones instead of 0.1 because it has to be an integer. And now if this isn't making sense to you, you can still do it the way you've been doing it, and it should work out just fine. So what I'm going to now do is just move this slider around. You're going to see it's more jumpy now that it's only moving by integers. And at 2, that's where it's going to actually make sense at. So now I know x is 4. Well, that means there's 4 quarters. Y is 5, so that's 5 nickels. So that'd be $1.25 so far. And Z, the slider, is 2. So that's 2 pennies, which would make for $1.27. Now, if you're the clever one that says, well, I could have done that without the system, great. I'm not stopping you from doing it without the system, but there it is in how you're supposed to be able to use the system in order to get this kind of problem done. All right, if you got any questions, let me know. Thanks.